Um, cool. So we're now recording. We just got a group of students here from the Larson Lab who are all doing blower door testing. So welcome. My name is Nick Clements. Some of you in the room probably don't know me. I'm the manager of the Larson Lab, project manager for the Renew America's Nonprofits project, along with Eric here and Monsef. And I'm happy to introduce Brad Biggin. He is the chairman of Alpine High Performance Products, a very close collaborator for going on 5 years now of our Industry University Cooperative Research Center, the BEST Center, and a company nearby to us makes amazing window products. So, Brad, I'll hand it over to you. You can use the arrows, spacebar to move the slides forward. And I'll watch on my iPad if any questions come in while we're talking, but
Okay.
we'll save questions for the end unless it's something really immediate.
Can everybody hear me okay? And I'll assume unless somebody chimes in that I'm doing okay. First of all, pleased to be here. I appreciate it. This is always fun. I love in particular talking to a lot of engineering sort of oriented minds. I am not that kind of guy, and you'll see that in a moment. I studied history and political science. But I love the technical aspects of our industry. I've been in this industry almost 20 years now, which is shocking to me. I am the chairman of Alpine High Performance Products. I was the CEO for 16 years, and we are a company that specializes, going on 45 years now, high performance fenestration products. We've got some really interesting things going on, but I am here really to talk about some more macro trends, and then we're going to bring this into retrofit technology and some really practical stuff that I just look forward to just sharing with you. We've got some of our products here we can pass around here, but this is really not an Alpine product thing. It's a fascinating time. It is the most fascinating time I have ever seen in a really broad, almost global sense, around the intersection of, once again, history, poli sci. This is a historically strange time relative to policy, and it is, as I'll talk about later, too late. Cat's out of the bag when it comes to high performance products, high performance building, because it's got nothing to do with federal policy as it changes from years to year. It has been unleashed by local, state, other sort of much more global and important kind of forces. And I will talk about what's getting ready to happen. I fashioned myself as a history buff that looks for trends and tries to use them to predict the future. And we'll see if I'm right or wrong, but I'm pretty sure some version of what I'm getting ready to talk to you about will be true. Here's what we're going to talk about. I'm going to go back and you're going to get a history lesson. I know if you're in engineering, maybe you hated history. I could not stand accounting and I was not good at math. So hence, we all have our propensities, but I'm going to try to do this in an interesting way that will hopefully create some sort of linear ability to understand this. We're going to talk about how glass and window technology has evolved, why it has evolved, when it has evolved. We're going to talk about evolving and emerging. I like the word emerging because it's already coming and pretty well here. New technologies. We're going to talk about our company and how we fit in there. It's not a sales effort, but it's an important part of kind of history. And then we're going to get into more practical stuff around retrofit technology. And I'm going to try to incorporate the emerging technologies into what opportunities it's going to create because it's fascinating to me. Let's talk about window technology. Window technology develops slowly. I think there's something called Moore's Law. I'm not sure I fully understand it, where capacity doubles every year, et cetera, et cetera. But window technology gets better and better, but it's only over thousands of years. Windows have been around since the dawn of man, but the uh, first real glass see-through sort of functional window that we can find in technology was a long, long time ago, 2000 years ago. Double pane technology, which is ubiquitous. It is really kind of what we all live in every day in almost all of our buildings, was really invented or at least patented a long, long time ago, Civil War days. Um, that is rope and twine that was between two pieces of glass to create the first double pane glass unit. Great idea. Nobody did anything with it for 100 years. These are rules. We all like rules that you can live by. We'll come back and revisit these rules, but these are something I developed as I was preparing for this, and I think is true. But remember this. Impactful technology that really becomes the status quo hardly ever develops as soon as the idea and the technology hit. Our company has been in the high performance world for a long time. We literally, for some reason, have seen, I've only been there 20 years, I've seen dozens of technologies come through our company for us to evaluate and help commercialize. We just have this spirit where we love to try to commercialize whatever we can. We love new things. If I see one more 4x4 sample of something that someone has an idea about, I will shoot myself in the head. So we are very, very aware of new technology, how it develops. I'm a huge student of new technology. I'm always trying to keep an eye out for Keith is as well, as you might imagine. So we do this kind of nerd out on it. The second rule is when technology is actually at the right time, it's understood, it is solving a problem, and it's adding value. When it does catch on, it is really, really, really fast. Let me use an example. Electrochromic technology. Does anybody, I think most of you probably have heard of it. It's the technology that changes from light to dark, and billions of dollars have been invested in that technology. It gets better and better and better, and I think at some point will. But it's never really kind of caught on in a big way because it's not, in my opinion, really solving a fundamental problem that the industry has, that they ask for it to be solved, and there's a corresponding value to it. I think it may, but that's a good example. But we're going to talk about some technologies and what happened and why they happened. And it'll hopefully draw some parallel here. There's almost always a triggering event. I'm going to try to point these out here. These are four really, really basic technologies. I've studied why they happen, when they happen, and how they happen. The Pilkington brothers in England developed something called float glass technology. How many of you are familiar or have ever heard of float glass technology? It's how almost all modern glass is made now. Essentially, it's embedded on a overly simplistic, but a floating bed of zinc, and it forms, and it's how 99% of all glass is made right now. It was invented, and it was revolutionary in 1959 by the Pilkington brothers, who made a critical decision that they could not commercialize it. They understood exactly what they had. They could not commercialize it fast enough, so they offered to license it to the whole world, which triggered its dramatically fast um, access by the industry. What I'm showing you on the upper left here, that is an actual image of how really large glass was made prior to float technology. They would melt it, pour it on a table, and people would actually just roll it like that. I'll show you some other examples. But what float technology did is it created a much more consistent quality, much faster, much bigger, because it was essentially continuously manufactured. You can see the evolution of size there. That triggered a massive change in the whole world. You remember 1959 when they invented this, it took 10 years to kind of really get it to the point where they could announce it. And they made that fateful decision to license it. Large companies came in, they saw it, they understood what it was, and it, in a very short period of time, dominated the industry. Some of those other photos are other examples of how glass was made prior to float technology. You can understand why it was so transformational, but it was a great technology developed at the right time, and it immediately took over the industry. What came out of that? Remember that double pane window patent that we talked about? Great idea, cool, whatever. But double pane windows, because the price of glass dropped, the size of it, the consistency of quality dropped, it became more commercially available around the world. And it really triggered a more accessible way for people to invest in seals and how to make double pane windows. And you can see how quickly double pane windows went from being a very small minority. You know, they were introduced in the 30s by companies here, but they very, very quickly dominated the industry. Now, I don't have slides in here about triple, but I have some similar slides about that. Okay, so you get people that are investing in equipment and really rapidly making glass. We had something that preceded probably most everybody in the room, with the exception of a couple of us, and it was called the oil crisis of the 70s. Who's responsible for energy efficiency? Richard Nixon, because he gave $2 billion to Israel back to support them in a war in the Middle East. And out of that came the OPEC oil embargo. It drove the creation of the Department of Energy. It drove an investment and an interest in energy efficiency. And out of that, the very first grant that was given by one of the national labs, LBNL, was to fund this nascent technology that was invented in the basement like this at MIT, of something called vacuum deposition coating of low-E glass. It was very cool, selective waves that you could separate infrared waves and light transmission you could see, but it was on vacuum deposition, which everybody understood could transform how the effectiveness of it. Everybody understood it, but it was really, really, really tough to make. They essentially gave a company that had, for all intents and purposes, bought that little tiny coater that could do 12-inch wide film on a little sample. I'll talk about those 4x4 samples. They bought that, they went to California, and it became what's called Southwall Industries, and they started coating low-E film. It was a pretty rough and tumble early stage. The very first franchisee of Southwall that used their film was a company called Cardinal Glass, Cardinal Industries. Cardinal Industries is now probably the largest coater, certainly in North America, and one of the largest in the world, and one of the leaders in manufacturing glass, low-E coating of glass. But they were the early franchisee of Southwall Technologies, who coated film. As a small company investing in this, they coated film, they bought it. And what is the first thing you do? I'm the chairman of the company. They went down to their chairman's home in Florida, and they put the technology with the coated film in their chairman's home. It immediately failed. It was very embarrassing. And they doubled down on how do you use that technology and put it on glass, because glass doesn't shrink and shrivel in film. And the rest is history. They weren't the only ones, but that's really the origination of how it became ubiquitous. When it happened, there were two companies that were fighting over the equipment side of it. One of them figured it out, actually in the US, partnered with Cardinal, and boom, $350 million invested. It went around the world, and it became rapidly the status quo. Vinyl windows. Anybody know why vinyl windows are such a thing? World War II, in Germany, you could not get aluminum. Very inventive. Somebody developed a way to make windows out of vinyl. It took a while to kind of get it all figured out, but when it came, it almost overnight replaced aluminum windows. Cheaper, better, faster. And that's how vinyl became a thing almost overnight. The dominant window material in North America by far, almost 80% market share, is vinyl. It's kind of stopped. So we're looking for the next thing. These are all S curves. Look at these S curves. Those are all of the same technologies I just showed you overlaid with one another. You all know what an S curve is. It's sort of from introduction to adoption. It's sort of a look at how they all overlay each other. The green, blue, and red forming purple and orange. That's because somehow they mix up the colors. It's not really different trends. There's really three colors there overlapping each other. But look at what happened from the mid 70s to around 2000. What do I have? 10 there? Everything became the status quo. And there are understood repeating. This is not just in Windows and glass. This is what happens in market innovation strategies. You see these technological breakthroughs, the investments, oftentimes triggered by policy or some sort of economic issue. You get the S curve, and then look at the last thing there. Market saturation and risk aversion. This is what's been, there's nothing wrong with this. This is very, very, very normal behavior but it's what's going on. The companies that dominated these technologies do it extremely well, have made a lot of money. The largest window companies in North America, fantastic companies. I've never really understood. I've been in this business 20 years. The windows look the same year after year after year. It's because they're harvesting the results of their earlier investments and innovation, and they have not only a risk aversion, they are disincentivized by changing the status quo. I have a story. This is a true story. I'm not going to name the company. You wouldn't know it probably anyway, but at one point it was a $4 billion company, not a mainstream name. Somebody in their R&D department that I knew well, ran R&D there, told me a story that is interesting and indicative of what we're talking about. They developed a vinyl window solution that was literally fireproof. It was phenomenal, fireproof. That's unbelievable. You can't do that. It's not consistent with vinyl. They melt. Fireproof. They worked on it. They worked on it. They worked on it. They made a presentation to the board of directors. And you know what the response of the board was? You will never speak of this again. Do you know how much damage that would do if overnight our whole industry got turned upside down and had to go to that solution? Once it's introduced, everybody will want it. That's a true story. Let's not confuse window styles with window technology. This is a fascinating fact here. US windows literally look pretty much identical to what they have for almost 400 years. Why is that? In the United States, 65% of our operable windows, does anybody know what they are? Sliding, vertical and horizontal sliding windows. Is that the way it is in the rest of the world? If you go to Europe, no. That's a uniquely North American thing. They have these products. Why did it develop? It developed because we developed on the East Coast. And a lot of windows were in larger homes in the East Coast, very humid, no air conditioning. You open the top and the bottom, you get circular draft. The $1 million question is, why does everybody still want them? And why does everybody do grids to simulate little tiny windows? Little tiny windows, that's all you could do back in the old days. So if you got a lot of those little grids, that you were rich. That's how you did it. Now you go back there, they intentionally put them on windows. It makes me crazy. But this is a holdover. So US window companies, they've evolved. This is a little bit overly draconian, of course, but it is still a style. We like sliding windows. What are the ramifications of sliding windows? Unlike swinging windows, we have narrow glass pockets because they have to slide past each other. Each of these, if you're swinging, you can develop wider glass pockets. So these are very inherent to our culture. Understand that. This is, remember R0?
Recording in progress.
Dinosaur stepping on somebody. R1, single pane of glass. R2, that's double pane. R3, low E coating, double pane. This is what I would call the state of the art 1995. Vinyl window, low E coated. At the same time, they put insulating gases in. 2024, that is the state of the art. what I would call not state of the art. It is the most dominant window trend. That's not much has changed. Okay, talking about history, that's not why we're here, right? So make it relevant, lighten up. All right, we're going to come back to technology because this is really gets interesting to me, at least. And I'm glad to share it with you, whether you agree or not. But we're going to go back to trying to understand this issue. Remember, technology finds a place when it solves a problem, when it's perceived as adding value, doing something new and unique, and the time is right. It's got to be kind of that right blend of events. This, I believe, is a true statement. It could be my opinion, but I will say it as true. The biggest problem in the built environment is the fact that we have really bad windows, and we have really bad windows uniquely in the US relative to our population of windows. We built a ton of buildings here, and we built a ton of them really poorly. What does that mean? These are typical facts. It's a small part of the building. It's a huge part of the energy loss. Heat goes in and out, et cetera, et cetera. This is a true story. These are true facts. And we just researched them. Half of existing commercial windows in the United States are really, really poor performing. Shocking amount of single pane still out there. Why is that? We'll get to that in a minute, but that was the state of the art for a long time. 20% think of if they are not single pane, they're oftentimes clear glass. They'll have a tinted glass, not low-E coated glass. They'll be in a non-thermally broken aluminum frame. There is a massive issue out there on the commercial side. Every one of you has watched TV. Maybe you do, maybe you don't. My kids don't anymore, but whatever. I don't blame them. If you have, in any given night, you've seen 3 replacement window ads. Champion this, 2 for 1 that, buy 1, get 7 free, whatever. There is a very robust, and I would say pretty mature replacement window business out there. It is really, really well developed on the residential side. It's still a pretty small portion of systematically replacing units. When I first got in the industry, the number one still dominant frame sold in Colorado was aluminum windows, shockingly. And all of those have now been replaced for all intents and purposes. Very few aluminum windows on the residential side. Having said that, in the commercial space, nobody does anything systematically. And we'll talk about why that is. And this is kind of a scary fact that in 2050, may or may not be gone, we'll see. I'm optimistic, that 90% of everything we have will still be here. But nobody does anything. And they do it for good reasons, not because they're cheap. They don't want to. They do it because it's a broken system. Think about replacing windows in a building that's occupied that has aluminum windows. It is monumentally expensive and almost cost prohibitive, to be perfectly frank. Consequently, nobody can pencil it out and make sense. You have to move your tenants. I mean, it's shockingly expensive. We'll get to some real life examples in a minute. I won't get into the details here, but the system is just broken. We were lucky enough to replace the glass in the Empire State Building, and it's 6,000 plus windows. This is 12, 15 years ago. I don't know. And that was a good aluminum window, double clear glass installed 35 years ago. That company really redeveloped its whole image, and it was a brilliant success by putting high performance glass in a pretty good frame at that time. And we said, well, everybody's going to do this. No, nobody does it. They had a motivation to rebrand the building, and they had the wherewithal and the foresight. But as a practical matter, it's frankly just too expensive. I'm not going to go through all this. These are just the sort of litany of what is available sort of more traditionally to fix poor windows. And what you see there is pretty thoughtful and fact-based exercise in what people actually do in commercial buildings when they have problems. It's actually pretty amazing. They will systematically get the caulk of silicone out and plug leaks, change some weather stripping, applied films. Um, I don't know if any of you know about applied films. We did not, but we've had a lot of experience. If there is a building in most major cities that was clear glass or even double clear glass, it is almost impossible not to find something that doesn't have an applied solar control film on it. And you could tell when it was. If it was 10 years before that, it looks horrible and it gets pulled off and replaced and pulled off and replaced. And that is a poor man's version of using applied films to manage a problem. And then my number one favorite way that people deal with really poor windows is they change the blinds and window treatments. It's actually true. Once I have to go through this, is really illustrate what I was talking about. Why nobody does anything is the cost of addressing a window is so high and the return on investment is so low that there's not really a really good way to do this. Don't be depressed. This is just supposed to be funny. I'm going to talk now a little bit about our company. It's going to be fast. I've already said, we're a 45-year-old company. We've been in the high performance space for a long time, for that entire time, very focused. We did that suspended coated film. Remember I talked about that the Cardinal guys put in their chairman's home? That's what we've done for the last 45 years until 2 years ago. We stopped doing that. We love it. That's what we put in the Empire State Building. It's a wonderful thing, but it can't scale. And we're going to talk about what we did to replace it. But we've always been glass centric, but most of our revenue comes from high performance windows. And the large majority of our competitors in certainly the commercial space almost never come from the United States, almost all Canada and Europe. It's a massive influx of imports. It's really quite shocking. But we've been around for a long time. We're kind of nerdy. We're in Louisville. We're 10, 15 minutes from here. We're kind of nerdy. We'd love to have any of you up that want to. We have residential windows. Once again, almost all high performance, somebody that has a high performance sort of L spec. We'll sell anybody, anything, anywhere. We're very proud of ours. We've got our products are price effective and all that. Our commercial business has grown dramatically because of some of the reasons I'll talk about in a minute. Our secondary windows is our newest product line, even newer than thin glass in our products, because it was born out of our experience with thin glass. I'm going to show you in some detail there. We're not going to go into it now. Now we're going back to history, my favorite subject, right? Boom, boom, your head's spinning around. This guy really is ADD. No, I'm not. Maybe. But let's go back to history. I'm going to try to weave this together now. Remember timing. Timing. Great ideas, great technology. They can work. I think Sage electrochromic glass does a spectacular job with electrochromic. They invented the whole subject matter. They're owned by one of the biggest companies in the world, but it hasn't quite caught on in a big commercial way. Remember, we're solving real life problems. We have nexus. People understand it. There's a solution and the timing is right. Is there a problem? I talked about the commercial retrofit market. This is true, whether you believe it or not, nobody does anything. The problem is not solving itself. There's not suddenly a big wave of people, let's go change our windows out. They can't. They really can't. It's cost ineffective. At the same time, this is very interesting. This is my perspective, but it's true. This is a broad statement, but I'm going to fast forward, assume it's true. There is rapidly developing energy codes, and it is highly inconsistent. It's all over the place. Very heavy on the East Coast and the Northeast, heavy on the West Coast, British Columbia, different parts of Canada, Seattle, Minnesota, Colorado is really caught up between the two coasts. I don't think there's a state that can really hold Colorado moved so fast under our current governor, in fact, that they've been sued multiple times. I've been right in the middle of watching them kind of pass new window requirements to meet Energy Star after it changed. And you would have sat in our industry meetings, you would have thought that they were the Wicked Witch flying across. It was like, how could you do that? How can you move that fast? Well, we're going to talk about this in a moment. This is the rapidly changing political sentiment, and it's where people have political purchase in order to allow them to do this. We go to Massachusetts. I'm not going to pick on anybody. Massachusetts has the most progressive statewide energy code anywhere in the country. Frankly, it's remarkable. They passed it as a follow-on in the regulatory work from a 2018. We're going to help address climate change. We're going to do our part. They have a long tradition in Massachusetts of being politically, not all parts of it, but politically a little more liberal and progressive. They passed that. They said, regulatory people, go and figure out how to do this. When they came out with the rules, I swear to God, this is a true story. I know it firsthand. People thought because part of it happened during the pandemic that they cheated. They did not offer to get public input when they came out. A bunch of people had gone into a room and came out with the most evil thing you've ever seen with the most progressive energy code. And it was brilliant. It was really, really quite brilliant because the most progressive parts of it were voluntary. Local voluntary called a stretch code. And if you really want to go further, you can do an advanced stretch code and then a super specialized stretch energy code. It was like, pick your lane, whatever you want. Well, as a practical matter, what they knew, nobody else around the country knew, was that the entire state had already previously adopted the stretch energy code. Sounds like that's just for a couple of wacky places, the boulders, as it were. But no, the whole state had. So the advanced specialized code was for the places that really want to take it further. And it was so far out there, so advanced and it's not by itself. It's popping up all over the place right now. Seattle is doing their own thing. Even Chicago is doing their own thing. I literally can't keep up with it, to be perfectly honest. But that's an example of what I would call local political will that, if I'm going to oversimplify it, says, I don't care whether you believe in the energy crisis, we do, and we're going to do our fair share and then some. Yes, sir.
You should say that the aggressive codes are primarily performance-based.
Yep.
Rather than prescriptive.
Yep.
Telling you what to do and what the component has to do. So it's more, and that's given rise to more energy simulation-based approaches to optimize the performance.
Absolutely. This is a very true statement. And it's done some really what I would call holy things. A lot of people would say very unholy things, but it's created incentives for products that are above average to find a place in the ecosystem and for investments to be made and for technology to kind of go from 4 square inches into field applications, etc. In the window world, what it's done, this is equally true story, very hidden. I spent a lot of time kind of making sure our federal government knows it has drawn massive wave of imports from Europe because there's very few US companies that even see it. I keep telling them, you're not in the discussion. Don't worry about it. And there's just, over $1 billion of additional imports that have hit the US, almost all kind of filling in that spot that was identified. And it's not hit you over the head, you have to do this. It's so incentivized that everybody does it anyway. But what it's done is it's created this acceleration. We're talking about timing. Now we're going to go back briefly here, and I'm going to try to do this fast and catch up. Remember this slide? This was that float glass. Look at how big the size got on float glass. Well, let's look at this technology. Look at the parallels here. This is a completely different way of doing things. Vertical fusion technology. Remember, you pour the glass on that zinc bath and it kind of floats along. This is unbelievable. I saw it. They do the same thing, melt it all together, and they literally pour it vertically, and it's perfect. I still have no idea how they do it, but I've seen it, and it's really cool. If I had my act together, I'd be showing you a little video right now of how it works. But it's called vertical fusion technology. Corning owns it. They developed it. They're a really remarkable company. They were the ones that put the first glass around the light bulb from Thomas Edison. That's sort of their whole thing. If it's glass, they dominate optic cables, etc. But what it allows you to do is create very high quality, very precise glass. I believe that they were working on this technology to compete with the solution that the Pilkington brothers came up with. I cannot verify that. I do not know that to be the case, but it was developed and patented in 1961. That's how long ago this was figured out. It got put on the shelf, cool. And they do that a lot at Corning. This is cool. Remember it. Put it on the shelf because nobody really wants it. Then someone said, let's put it in race car windshields. They need lightweight, and this is lightweight. It's durable. It's really cool. And they had a whole team go out and try to put it in the race cars. They put it in race cars, and they quickly said, no one wants to pay for this in race cars. So they put it back on the shelf for a long, long time. This is a true story. Maybe they brought it out a little bit here, a little bit there, but it was Steve Jobs who had a plastic cover on his first iPhone. He had a beta thing in his pocket. His keys kept scratching it. He was talking to Corning about something else. And he said, you put that glass on here. It was really kind of that much of an afterthought. It was like 90 days before the launch. And it's this funny story of Steve Jobs calling the chairman of Corning, just, give him that message. And the executive secretary for the chairman saying, he's busy. I'll take a message. He said, do you know who I am? Anyway, he called back, had that conversation. Corning said it was impossible. He said, do it. They said, okay. And they did it. That's how it got into the first iPhone, and it became widely used. Gorilla Glass. You guys have heard of Gorilla Glass. It's on your iPhone right now. It keeps getting better and better and better and better. That was the first application. And then glass came out in flat screen TVs. This is what really changed the world. Corning has a big position in flat screen TVs. The TVs that are on your phones, but it attracted other companies. Remember that Pilkington brothers I was telling you about? Funny story. Love Pilkington. We have a great relationship with them. They're owned by AGC, the largest glass company in the world, based in Japan, Asahi Glass Company. Now, Pilkington invented float glass, but they never ever coated any low E. It's very, very strange. They're one of the only companies that continue with pyrolytic, but they're really, really good. They developed through this large Asahi Glass Company alternatives using the float technology to create very, very thin glass. They have a big position in this competitive market. And then you have AGC also in that market. AGC is kind of taking it to the next level, but only, so they're all three big players in thin glass, and there's some other specialty folks. But flat screen TVs did something that nobody else could do. You see those little size guides there? When it first came out, you got iPhones, you don't really need big sheets. So they got bigger and bigger and bigger because there was more of a commercial demand for it. But it was the size of flat screen TVs and the introduction of these other competitors and the massive scale of flat screen TVs that caused big investments during the 2010s, really, to dramatically scale the production and the size of the master sheets. Let's go back to timing, right? What do you need if you're going to make windows? You guys don't make windows, so you wouldn't know. We start when we make an insulated glass unit with a really, really big piece of glass. The thing we always ask for, give me the biggest glass you can, possibly that we can handle. big, because we make multiple glass units out of a big single pane of glass. We don't cut one and throw it all away. We try to get as much yield as we can. And the bigger it is, the better. If you have a little sheet, that's cool for 4-inch samples or 12 by 18 samples, but this created a master sheet size that was accessible now to actually think about making architectural applications, windows with glass. As important was the fact that these other competitors came in to scale capital investment and the price dropped. Remember Corning? Fantastic technology, still fantastic technology, but they've got competitors doing this with a soda lime application. Better or worse, who does, I don't, but the practical outcome of that: scale, price drops, scale, price drops, automation, price drops. So now we have large master sheet size. You have a moderately realistic price, and you need an early adopter to do some of the heavy lifting. Raise our hand, proud to be that early adopter. We'll do literally anything at Elpin. We are perpetually intellectually curious. Remember, we were making that film, can't scale it, very frustrating. We more and more and more and more. We just worked harder and harder and harder. Smartest person we know, we owe a debt of gratitude, named Steve Selkowitz. He ran that LB&L. He's the guy, when he first started out as a hippie with LB&L, was responsible for that first research grant to Cardinal, or to Southwall. It became Cardinal. And he's just fascinated. He's seen this for a gazillion years. He said, we actually have a patent from 1991 on thin glass triples. It expired before its time, remember? So he said, I'd like you guys, just pay attention to this. We said, anything you say, Steve. We brought some glass in. We called Corning, we called AGC, we called Pilkington. We knew Pilkington, they sent glass in. We ultimately did business with all of them. We do more and more with Corning. We love Corning. But we spent the last 5 or 6 years doing the heavy lifting that you guys do in labs here. We looked at it, we broke it, we thought about it, we cut it, we drilled holes in it. We tried to figure it out. That's what we do. There's not many companies like us. We like this. We like iterative processing. We like iterative development. We like to nerd out on it. We said, can we make it? Our top salesman said, I've got windows with our glass in. Make me one. I'll put it in my house. We'll just see if it stays, if it breaks. We thought when we got big glass in, like everybody else, that it would break the first time we touched it and looked at it. Technical people said, nope, very durable, very durable. They were right. We played around with it. We started putting it in, and then we did an experiment. We did 2 things. I took something like that to a trade show in Chicago. We brought it out because we were on the same flight. It was the Greenbelt, to a guy that we owe a debt of gratitude, great deal of respect. It was a while ago, crotchety. He's been in the commercial business for a long time, successful, pretty thoughtful and progressive, but based in reality. He said, that's cool. First building you put it in, when the wind blows, it'll break. But I don't think so, but maybe. So we went to Greenbelt, we came back. We had 50 square foot stuff of this. We had a friend in Kansas City with a big test thing. We made a humongous unit. And we said, let's see what happens if he's right. Well, we don't have to spend a lot of time on it. We designed a process to have the wind. You guys were just doing the blower door test. We did a positive, negative pressure. And we ramped it up and ramped it up and ramped it up. These test guys, they just love testing stuff. We said, go till it breaks. And let's go super, super slow motion. And let's see if the glass cracks. Super slow motion, a little bit better than we thought. 1/4-inch glass, equivalent of supposedly 232 mile an hour winds before it broke. And when it broke, it was pretty spectacular. The 1/4-inch glass on one side broke, the 1/4-inch glass on the other side broke, and the thin glass sort of ballooned out before it broke, and it broke because it got hit by the other glass. So he was wrong. Craig was wrong. We put it in temperature cycling, 270 degrees, because we're sure that thermal shock would break it. It didn't. Funny story, we sent it to the lab to get tested. Got a phone call. The guy said, good news, bad news. I said, always the bad news. We were moving the crate to the test lab. It fell off of the forklift. We broke every piece of glass in there. True story. I said, what possibly good news could you have? He said, none of the thin glass broke, just the outer panes. I said, oh, we'll take that. Anyway, so we're gonna go really quick now because I'm behind schedule. But remember, timing. We did our evaluation. We brought it to market. This takes years to do this stuff. We put it in our system. We put it side by side, same price, same performance as that film. Let the market tell us what they want. Well, that was pretty fast, sorry. And then we said, how are we going to scale this? There was no equipment. We had to go out, design the equipment, collaborate around the world. Ended up getting the equipment, some of it out of Germany, some of it out of Korea, some of it out of North America. And it took years to get this in. We went out and got money, DOE financing, grant financing, matching funds. We installed the equipment. We've now brought it to market. We've developed the product. And we have a little bit of a head start because there are now 6 companies, most of which are buying the equipment that we spec'd, that are now putting it in. And flattery is the best form of, or imitation is the best form of flattery. We're flattered. They're all making some mistakes, but won't talk about that because this is being recorded. Oops, sorry. What did I do there? I'm good. But my point is, it's my prediction. I think in 10 years, traditional triple panes will be the story will be what happened to traditional triple panes. Triples will become very, very thin. Triples will be very common. Where people are using triples now to become quads. Ask us how we know. Thin glass centric product lines. Thin glass, what is it? This is thin glass, 0.5 millimeters being passed around, the equivalent of two playing deck cards. It's flexible, remarkably flexible, multiple times flexible. That's an advantage. Retains its shape, but thermal stress, wind loads does not change it. We put 2 lines in. You are the first people on the face of the earth to see a side-by-side image with both lines. The line in Pennsylvania, the image on the right, now fully up and operating. This is photos from yesterday. I spliced in here. The line on the left is the photos of our line in Colorado. It's a very exciting time. We make thin glass triples and quads, but it's nice. What's it all mean? It's a solution that allows the same form and fit and weight to drop into existing solutions. We're not trying to change anything. We're not trying to have you hook up electronics, etc. You got a window, we'll drop in a triple where you have a double. If you have a triple, we'll put a quad in. Right place, right time. Let's get into retrofit stuff real quick. This is very, very practical. There are 3 options here. First of all, nobody does anything, but if they do, remember we replace the glass in the Empire State Building, double clear, drop in a thin glass triple, same weight, same concept as the Empire State Building, but it's glass instead of film. It is a very, very low cost way to solve the same problem here. What's different about a thin glass triple? Same form. Take the same pocket your double pane was in, you now have triple pane. It's a 1/4 pound more a square foot. Doesn't matter. No one cares. The performance, 2.5 times better. If your gas is all leaked out and you're replacing it, that's what you can expect. What is the incremental cost over replacing it with double pane? I am not allowed to tell you anything about pricing. It is our most incredibly important secret. If I was to say something, what is the incremental cost of making something with a thin glass triple? Similar to, I'd say, go to McDonald's, order a small order of fries, and that would be pretty similar to the incremental cost of this solution over what is out there right now. This is not just us. This is our biggest competitors. and where we're all sort of getting things. It doesn't mean that our thin glass triples are the same as the cheapest double pane. That is what the actual incremental cost is if somebody wanted to understand. That's a game changer. If you can't replace the glass, you don't have a big enough pocket, it's replacing the glass doesn't solve the problem because you have horrific windows, or there's a lot of other reasons. The most typical thing is that people will replace windows. There is a dramatic increase in the light commercial market that used to be all aluminum is now almost all being replaced by alternative products, fiberglass, PVC, and other alternative products. And those products are now scaling themselves up into mid-commercial. When do you do it? You do it when you need to. Window replacement, once again, very similar, but some important differences. We have windows in this space. In the sake of time, I'm going to keep moving forward. And then this is the one I'm really excited about. This is a newly patented product as of about the last 4 years ago. It is remarkably simple. I thought I could impress my kids. Being a history major, it's kind of hard by being on a patent on this product. And Michael, you probably have like 400 of them, but they were not impressed. But it's a remarkably simple product, a high performance frame using initially thin glass. Because of our experience in the Empire State Building and knowing that nobody does it, let's make it really easy and just, we know we have to over insulate that horrible aluminum frame. Let's get something tight, light, pop it in. Why doesn't that work? And it did. So we then took that and we made a little micro insulated glass unit. Those are two solutions, Winsert Light, Winsert Plus. Super simple, right? Patent office writes back and says, this is stupid. This has got to be done by someone else. No, no one's done that. So patent. But it's a very, very easy and we hope highly replicated and copied solution. It is literally nothing more, nothing less. I'm going to go quickly here, than something with that little frame. That little frame was our single hung window we no longer make. It was just, that's how kind of rudimentary this was. You put the glass in, you put a low E coating, you put a set, remember that applied film, you put it on there, you pop it in, it takes 5 minutes, doesn't cost much. Why is that so complicated? It's solves a problem. Nobody ever replaces historic windows because it's super expensive. You can't do it from the outside and change the visuals. Once again, very simple. Just goes in very, very quickly here. How does it work? We understand enough about science, not as much about how thermal properties work, but we're pretty good to know when you look at a single pane, non-thermally broken aluminum window, and you look at the cross image, what's going to be the worst part of it? It's not the glass. It could be clear glass. It is that aluminum frame. That's why they make aluminum pans to fry stuff in, because it's such a good thermal conductor. We have to over insulate that aluminum. That's part of what the magic here. Super lightweight. That's one installed in the Empire State Building just for fun. Good picture. What's different about it? It can improve existing windows without replacing them. It's not for every solution, to essentially the equivalent of a triple or even better. Boom. We got this 8 to 12%. You know how we got that? We did 2 case studies earlier, paid by other folks. We priced an installed Winsert, seemed like a reasonable price. We put it in, we figured it was going to be 25 to 50% on window replacement. After we got them all in, after they were installed, turnkey, successful, easy breezy, we found out what they had both done. They had both solicited multiple bids to replace windows in the 2 buildings. The first one, the lowest cost of that window replacement, made our total installed cost, which we thought was fair, 8% of the lowest bid. The median of those bids was half of the value of the building. That's how expensive it was. That's why no one does it. The other building was 12%. We sat there and said, damn, why did we not mark that up more? But that's not the point. We really haven't changed the price. If anything, bringing it down. Enabled by thin glass. Some of the case studies here. I'm not going to go into that. Other window retrofit options. I talked about There is nothing wrong with solving bad windows by sealing them up, by using some of those existing technologies and solutions. Those are, tried and true. There's nothing wrong with them. There's a lot of options, but when people can't replace them, understand why. Some final thoughts here. Got to get my glasses. Those of you involved in evaluating windows, it's shocking to me. Understand before and after for the full window assembly. There's this weird, almost deceptive thing that goes on in our industry. Center of glass, center of glass, center of glass. We have the best center of glass of anybody in the face of the earth. We don't care about that. It's the edge of glass, the window frame, before and after the whole thing. Always remember that. It's just remarkable to me. There is plenty of certified data. You know how, as well as anybody, how to get this. It's not that complicated. Glass replacement. There's a remarkable tool set, easily accessible in LBNL. It's one of the most amazing DOE tools, Windows software. We use it every day so you can accurately kind of predict things. Secondary windows. Every window sold in the US now has what's called an NFRC, National Fenestration Rating sticker on it. And it's designed so that we don't cheat. We all test our windows to the same size. Labs test them, and then you can simulate up and down from those physical tested results. So companies aren't out there saying, we're R422, we're spectacular. It's just doesn't work that way. Where's your sticker? I'm going to go on a rant here. European competitors, I don't care about anything as long as we have a level playing ground. My least favorite, albeit successful, they kind of cleaned up their act, competitor. First trade show I went to was in Denver, National Passive House Show. R equals 12. We don't know much about much. That is insinuating that your window performance is that's 0.08, I think. We don't know much about much. We know a lot about that. That's center of glass, BS, not NFRC certified, and that's just wrong. It's implying this performance that's not right. We've been competing with them for many years. They've taken their website up and down. They've kind of got their act together now, but that's sort of makes me crazy. Final thoughts. Understand air infiltration, the most misunderstood, underappreciated element. So some of you were doing blower door tests here. I mean, we almost a huge amount of our projects do blower door tests. I hate doors. Doors suck, particularly if we don't make them. But that air infiltration makes all the difference in the world. It really, really does. So important. Pre and post install. Now Massachusetts on multifamily requires building size air blower door tests. When you're doing them, follow the rules. That's another issue. Thermostat set points. People do a lot of modeling. When we first did the big model for the Empire State Building, one of many things, it didn't pencil out. Then someone, it's a $350,000 energy model, said, oh, we're going to change the thermostat set points, before and after from all these upgrades. And they did. And it not only worked out, but the ESCO that was responsible for that project that had guarantees of those energy savings that more than exceeded it. So it proved to be true. Thermostat set points are really important. It's okay to think about occupant comfort. And then finally, this is from Steve Salkowitz. He's going to die. He's retired, but he's working harder than he ever has, as I would expect him to. This was his mantra. Deal with the shell before you deal with the HVAC, if you can. There's this weird thing, and I think, I'm not sure we'll ever get to it, where people are upgrading the HVAC system, then they're going to go fix the windows. First job we did with Windcert did it exactly that way for reasons that mystify me. And there was a really crotchety and scared the heck out of everybody guy that managed it. He said, God, I wish we had done it the other way because I got way too much HVAC now in the retrofit. And it's okay to pay for quality. That's all I've got. I don't know how I did. That's not much Q&A time. Sorry about that. Once I get rolling, you can't. Yeah.
All righty. Thank you, Brad.
Thank you.
All righty. So
Maybe let's start in the room. Yeah, that one. Yeah, go for it.
What is your adhesive on the windshield product, so you don't have moisture or air?
It's a great question. Yeah, the number one, people that understand thermodynamics, it's the number one media. Don't you create condensation? And that we studied it, the heck out of it. You know, even the Best Center has done a lot of collaborative follow-on because there's not a lot of academia out there. As a practical matter, we almost never see it. When we do see it, it really almost goes away. Ultimately, we have some venting instructions. We tried to predict it, but it is, as a practical matter, it just almost never shows up. It's we're using a double gasket around. It's a compression fit gasket. There is not one existing aluminum window that is square. We discovered none of them are square. So we have large gaskets, a compression fit. It's we can change the inside and the outside, but it's all designed around a compression fit system. And then we can vent it in some situations. Yeah. Yes, sir.
What's the best application for a secondary window? And roughly, you mentioned 10% of the cost.
Yeah, it could be a little deceiving if you're replacing windows and you're in a commercial application. I think those are probably pretty good rules of thumb because it hasn't gotten any cheaper. It's just it's cost prohibitive to replace windows in a lot of buildings, so consequently nobody does. There are other developing solutions in our space. And the very, very best thing that can happen is for there to be other secondary windows that really scale. The DOE, the Building Technology Office, it's now part of some other thing, et cetera, said, Windsor, cool, great. We were going in a lot of federal government buildings, and then Doge might have come by and kind of skimmed that down a little bit. But that's another story. But they said, that's a great idea. We've got some extra money in our budget. Let's incentivize a prize to create more secondary windows of different solutions. They got to the first step. They got 32 different solutions